Alright, Microtronic fans, here's the demo of the latest new feature of the Microtronic Next Generation or Microtronic Second Generation Emulator, which emulates this classic Microtronic 2090 computer education system. So many folks and fans of the Microtronic actually don't own the 2095 cassette interface, which allows you to store programs on cassette and also read it back. So we figured, okay, given that we had figured out in previous work how to actually connect to the cassette interface of the Microtronic and emulate the 2095, why not add this also as a new feature to our new Arduino-based Next Generation Emulator. So I'm going to demonstrate how to download programs from the Microtronic Next Generation into the real Microtronic, and vice versa. I'm also demonstrating how to upload from the Microtronic, save your programs onto the Microtronic Next Generation SD card. Alright, first we need a little program so that we can actually store it on SD card and then transfer it from the Microtronic Second Generation or Next Generation into the Microtronic. So I key in a little program here, starting at address 0, a little counter program, display 1 register, starting at register 0 on the display. Next I'm adding 1 to register 0. I'm also outputting register 0 to the digital outputs that should show on the LEDs then. And then next I'm going to address 1, so that executes in a loop. Let's run this and we should get a little counter. There you go. You also see that the output LEDs count nicely in binary. So there are different display modes. Here you see this mode actually shows you the opcode and some mnemonics which are being executed, so you get an idea what's going on. We can also slow down the emulator a bit by throttling the CPU basically. So then we can even read better what's going on, right? And you see how also the LED counting slows down. So there are other display modes. Here you actually see the register contents. There are 16 work registers. You see that register 0 is the one in which we are counting. There is an extra register set. All of them are 0 currently. And this is the mode that only shows the output basically, or in big font. Well, let's make it a little bit faster again so that we get an idea of how fast the emulation runs. You can see it's actually quite fast if you look at the LEDs, and we will see how that compares to the real Microtronic. Okay, so let's stop this and save that program to SD card now so that we can then transfer it to the real Microtronic. So we are executing PGM2, which is being used for saving programs to SD card. So we can just give it a name here, and to keep it simple I just call it P for program. Now it already asks me whether we should, rather than saving it to SD card, whether we should transmit it to the real Microtronic by emulating the 2095 cassette interface. So I'm saying no here, we want to save it to SD card. And yeah, let's do it fast. And the file already exists, so I'm replacing it. So this is yes and no buttons, enter and cancel. Alright, there it is. So let's make sure we really have it on disk, on SD card now. So I'm clearing the memory. Next thing I'm trying is I'm seeing if I can read it back from SD card. And this is HOID PGM1 is the load function. And there is our program P. I can just load it. And now we should have our counter back. And indeed, there it is, right? So now we want to transmit this program into the real Microtronic. To do so, it is actually being read in from SD card from the file we just created. First I'm clearing the memory here again. And now I'm using PGM1 to load the program again, this time not into the memory of the Microtronic Next Generation, but over the wire into the Microtronic 2090. So let's select our program. And now I have to arm the Microtronic to receive the program. This is again, just make sure it's all empty. RAM was cleared. It's all zeros, as you see, as we step through. No program is there. Let me also run it. Nothing happening. Okay. And now let me arm it and initiate the load from tape, or from the tape emulator in this case, right? Hold PGM1. And now the Microtronic is waiting for the program to be transmitted. And I hit enter here for yes. Now we want to send it over the 2095 emulation into the Microtronic. Let's see how that works. You see that the LEDs are blinking here, so it's receiving something. And you also see what's being transmitted. So at that point, you know, we can just stop the process, hit reset on the Microtronic side. And I can also just hit reset here, because otherwise it will just keep going until the end of the memory, which is FF 256 address locations only. So let's make sure, let's check if the program got transmitted. So I'm having a look at the Microtronic memory now, and indeed we see F10, meaning display 1 register starting from register 0, add 1 output, and go to. There you go. Maybe let's also compare this to the emulation. Actually, I was confused a bit because I saw on the Microtronic memory that there was 000, which is basically a knob operation, and I always thought, okay, there was some error in the transmission, but it turns out that I also have this error or this knob opcode in the original program, so everything is fine. Okay, let's also run the emulator with that program, and I should start at the right address, start at 00 and run it. And there you see this is now running a little bit slower, but if I adjust the display mode, it's running actually faster than the real Microtronic. So this demonstrated how to download programs from the Microtronic Next Generation into the real Microtronic. Now let's do the other direction, save or upload basically a program from the Microtronic into the Microtronic Next Generation, so we can store it on SD card and save it back later, right? So let me stop the running programs here. For this we are now going to write a little program on the Microtronic side, and this time we make it a little bit different. So how about display 6 registers starting at register 0, add 1 to register 0, and then we move register 0 into register 1, we move it in register 2, we move it in register 3, we also move it in register 4 and in register 5, and then again we do the output of register 0 to the digital outputs, and we do a go to 01 again. So now we would expect the same counter, but this time with 6 digits, right? And indeed there it is. You see, of course, it's running a little bit slower now. And now suppose we want to store our program over our emulated 2095 cassette interface. So what we do is, first I'm clearing the program here, and now I'm using PGM2, which is for saving a program. But rather than saving the program from the internal memory of the Microtronic Next Generation to the SD card, we are now receiving the program over the wire and saving it to SD card. And I give a different name. Let's call it Q this time, right? Or I don't know, R. Let's call it R. Hit enter. Now it asks me whether it should emulate the 2095. I'm saying yes there. But first, let me initiate the transmission of the program on the Microtronic side. I'm using Hoid PGM2, So this is going to send the program over the wire. It's now ready for the start command basically, and the start command is going to be given as soon as I hit enter here, and then you see that that program is now being transmitted over the wire and the opcodes are arriving here. That's already it, right? It's a short program, so we can stop this here, and you see saving automatically stopped on the Microtronic Next Generation. Let's make sure the program was received correctly. So I cleared the memory again, right? Nothing in there. Alt PGM5 always clears the memory, and now let me load back the program from the SD card that we just received. So with the file browser I can see that we have the program R now, which is the one we just received, and let me just load that back. This time we want to load it back from SD card, not from the 2095 over the wire. So I hit no, and yes, let's do it fast. Alright, there it is. And if we look at it, so this is a good listing mode here. You can see that, okay, F60, 510, right, 001 means move register 0 into 1, move register 0 into register 2, and so on, all the way up. Then the dot is digital output to the ports, and go to 01. Alright, so it was received correctly, and we should be able to run it. And sure enough, there it is. We can now nicely see that all the 6 0 to 5 registers are counting in the register display, right? You can also make it a little bit as fast as possible. So that's the fastest here. In this mode it's a little bit slower than the Microtronic, the original, but that's due to the register display and the other goodies. So if we have it in this mode, then it is faster than the original, which we can run in parallel here. So, alright guys, that's it. So, if you think Microtronic second generation or Microtronic next generation is not something you really need because you already have a real Microtronic, maybe consider, you know, supporting the project and getting it anyhow, because you will have a 2095 cassette interface for your real Microtronic, and those are incredibly, or let's say impossible to get these days on eBay. There must have been produced a couple hundred maybe. They are all gone. So I am lucky owner of one. I'm happy to have a real 2095, but many folks do not. So this might be your solution to cassette storage on the Microtronic. Thanks for watching.